Today we're going to talk about section 5.8, which is called the rational zero theorem. If you remember previous lessons here, one of the things that we've been trying to do is we've been trying to find the solutions to these different polynomial equations. And when we've been trying to find the solutions, we've been trying to find the values of x, or the variable, that make the equation equal to 0. And these solutions are also called the zeros, okay? And they're also called the roots of the solution, okay? And we've taken a look at many different ways to do that. We did the quadratic formula a little bit, but mainly we've done some factoring, okay? And then we also tied in a little bit of that synthetic division, synthetic substitution. If you remember, okay, that's where we did this big L thing, and we had a number out here, and we did it, and we tried to find that number right there, okay? And if something was a solution, or it gave us a 0, okay, this, if you remember, this was our remainder, okay, and we wanted that remainder to be 0, okay? And that was the value of our function, the value of x that made the equation equal to 0, was that number out there, okay? And this number here, again, was called a 0, a root, a solution, and it also is called a factor, okay? And if you remember, a factor of something is something that divides in evenly, and if it divides in evenly, it has a remainder of 0. Okay, so we're going to tie a couple of this, all this stuff together here that we've been doing, the first and second half of the chapter, okay? And the rational zero theorem is this, okay? What it is a little theorem that tells us all the different possible solutions, possible zeros that might work in a function to have it equal 0, okay? And what it says here, it says there, let's see here, I'm going to write this down. The rational zero theorem, okay? It gives us the possible zeros, the possible solutions. Okay, some of them might work, some of them might not work. Okay, and what they do is they take the form of P over Q. Okay, and that's what this is saying right here. Okay, where P is a factor of the last term. P is all factors of the last term, which in an expression in this case it would be 10. It's the constant at the end. And then Q is all factors of the first term. Okay? And they create a fraction. Okay? And it's all the positives and all the negatives. You know, it might seem a little weird here. Okay, but I have a little example. Okay? And if I wanted to list all the possible zeros of this function right here, okay, when asked to write all the possible ones, we're going to write it in the form of P over Q. Okay, and the P is the constants of the last term. And this one, I'm sorry, the factors of the last term, the factors of 10. The factors of 10 are 1, 2, 5, and 10. And a really good easy place to get those from would be your factor sheet again. Okay? And then the Q, the denominator, is the factors of the first term. And the first term here is 4. And all the factors of 4 are 1, 2, and 4. Now, how do you read that? What the heck does that mean? Okay, these are all the possible values of x that can make that equal to 0. And I'm going to show you how to read this. Here's how we would read this. Okay, if I started with the numerator being 1, okay, it could be 1 over 1, 1 over 2, or 1 over 4. So 1 over 1 is just 1, so it could be 1, 1/2, 1/4. Then I could let the numerator be 2. It could be 2 over 1, 2 over 2, or 2 over 4. Now 2 over 4 we know is a half, and a lot of these repeat. 2 over 2 is 1, and so on. And then I could have 5 over 1, 5 over 2, 5 over 4, and 10 over 1, 10 over 2, and 10 over 4. There's a whole bunch of them. Those are all just the positives. Okay? Then I can make each one of these things negative. So there's a whole bunch of different possible zeros. And rather than writing out each individual one like this, okay, we're going to leave it in this form. And I'm going to erase that again, so we get a little cleaner picture of it. Okay? Don't forget forget the plus and the minus though. There's always the positives and the negatives. And once again, the numerator came from the factors of the last term, which was the 10. 1, 2, 5, and 10. And the numerator came from, the denominator came from the factors of the first number. Okay? So this is the form that we're going to leave it in. It's a lot cleaner, a lot neater than writing out all the individual ones. But just remember, there's a bunch of different ways to read this. 1 over 1, 1 over 2, 1 over 4. And then 2 over 1, 2 over 2, 2 over 4. And a lot of those will repeat. A lot of those will be fractions that can be simplified, which again will be repeated. And last but not least, don't forget it's all the negatives as well. So there's a whole bunch of them. Okay, but again, these are just all the possible ones. Okay? And this is the first thing you're going to see in your assignment. They're going to ask us to find all the possible zeros, okay, of each function. Okay, well, all the possible zeros, again, are going to take the form of p over q, a plus or a minus, and then I write the big fraction bar. The numerator comes from the last term, so the numerator comes from the factors of 16. And again, if you list the factors of 16, 1, 2, 4, 8, and 16. And they don't necessarily have to be written in order. If you were to use your factor sheet, you could write 1 and 16, 2 and 8, and then 4 and 4. We just write 1, 4. So they don't necessarily have to be in order. Either way is okay. The q comes from the factors of the first term again, and that's 1, 2, and 4. And all the pluses and all the minuses, and a whole bunch of them there. Again, don't write them out individually. Let's leave it in that form. Okay, here's another one. How about this guy? What if I wanted all the possible factors of this? Okay, again, the numerator is the last term. That's my 10. 1, 2, 5, and 10. Or you could write 1 and 10, 5 and 2. Either one's okay. And the denominator is the factors of 3, 1 and 3. So again, it's 1, 1 over 1, 1 over 3. 2 over 1, 2 over 3. 5 over 1, 5 thirds. 10 over 1, and 10 thirds. And all the negatives as well. Okay, one last one here. Okay, maybe take a second and see if you can do this one by yourself. Okay, I'll help you set up. It's going to be P over Q. See if you can write all those. Take a second, push pause, and see if you can write them out. Ready, set, go. Okay, all right, let's give it a whirl back. The numerator comes from the factors of 12. 1 and 12, 2 and 6, 3 and 4. You can certainly write them out in pairs like that. They don't have to be in order. The denominator comes from the factors of the number in front of the first term. I don't see a number there, but it's 1. Okay, this is a 1x cubed, and the only factors of 1 are 1. So all my factors here, all my possible zeros would be 1 over 1, 12 over 1, 2 over 1, 6 over 1, 3 over 1, 4 over 1, and then also negative 1 over 1, negative 12 over 1, negative 2 over 1, and so on. Okay? So that's the first thing. Listing all the possible zeros. Some of them will work, some of them won't work. Okay? All right, here we go. We're going to take this a step further. Okay? Now, what we're going to do here, okay, is we're going to do a little synthetic substitution, and we're going to do a little test to see which ones work and which one, well, we want to find one that works. Okay? And in order for it to work, it has to give us a 0 for a remainder. So we're going to do this business. Okay? And we're going to put a number out here, and we're going to do all the work. And we want it to give us a remainder of 0. That means it's a factor, it divides in evenly, and it's a solution. Okay? All right. So let's give this one a whirl once. Okay? First of all, I'm going to list all my possible ones, my P over Q's. The factors of the last number are 1, 3, 7, and 21. And the factors of my first number are a 1. So those are my possible ones. And when the denominator is a 1, I really just have 1, 3, 7, 21, negative 1, negative 3, negative 7, and negative 21. Okay? So, okay, this is what I'm ultimately getting at here. I need to find one of those, so when I plug it in here, it works. I'm going to kind of set it up here. Remember synthetic substitution. The coefficients go up here. And one thing that a couple of you guys missed on your test and on your homework assignment that you're going to want to pay attention to today, again, is make sure all the exponents are accounted for. Again, if it's missing a power, we would have to write a 0 in there as a placeholder. But I think I have them all here. Third power, second power, first power, and it also has to have a constant. So I think I have them there. Okay. Well, now I want to find out, I want to pick one of these and see if one works. Okay. Just for simplicity's sake here, maybe I'll try 2. I'm going to try 2 over 1, and let's just see if this works. So I'm going to drop this down. 1 times 2 is 2, and then we add, if you remember. I get 5, 2 times 5 is 10. I add it, it's negative 15, 30, and that does not equal 0, does it? So I know that the number 2 is not a solution. Okay? So we got to go back and we got to try it again. Pick a different one. Okay? Maybe I'll try 3. Okay, I'm going to try 3. Try this one once. Let's see if this works. And again, I'm just randomly picking here to start with. Drop down to 1. 3 times 1. Remember, I multiply and add. 6 is 18. That's negative 7 when I add. 3 times 7 is negative 21. Aha! There, I got it. So I know that one of my answers is x equals 3. It's right there. 3 gave me a 0. Okay? Well, how do we find the others then? If you remember that fundamental theorem of algebra from a few days back, if it's the third power, it's going to have 3 solutions. And they may be real solutions, they may be imaginary solutions, or a mixture of both. But I should have 3. We've got one of them. Okay? Well, how I find the others is I take this leftover stuff, and we're going to transform it back into x, and it goes down a power, x squared plus 6x minus 7. And I want to find the values of that make that equal 0. Okay? And the most common way that we're going to do that is we're going to do factoring. Scoot this up here just a smidge. Okay, and I'm going to see, is this factorable? Okay, well, x squared is x and x. The only factors of 7 are 1 and 7. And can I use 1 and 7 to get positive 6? Well, there's a 7x, there's a 1x, and I need 6x. And I think I can do it if I add a positive 7 and a negative 1. So I'm going to go plus 7 and negative 1 to get it factored. Okay? And then I find my solutions. And you can do this one of 2 ways. You can remember, you can set each one of these equal to 0 and solve it. Or if you remember the shortcut, if it's x minus 1, positive 1 is a solution. And if it's x plus 7, negative 7 is a solution. Okay? And there's my other zeros. Okay, once again, if you remember way back at the beginning, I said we had to have a third power, or there's a third power, so we had to have 3 solutions. Well, I found them. 1, 2, 3. Okay? And again, obviously there's a little bit of work to show. You need to prove it to me that this one equals 0, and then show the factoring to find the other ones. Okay? And just a curiosity's sake, is the number 1 here one of our possible solutions? Yep, 1 over 1. Negative 7 over 1 is another one. So out of all those that are up there, only 3 of them work. Okay? All right, let's try one more here. Let's try to find all the possible solutions here. First of all, my P's and Q's. Let's figure out what our choices are that we have to choose from. Okay? The numerator comes from the factors of the last term. Well, there's only 2 of them, 1 and 2. The denominator comes from the factors of the first term, which are 1, 2, 5, and 10. And all their pluses and all their minuses. Now there's a bunch of them there. Okay? And just randomly guess and test. I'm going to try 2 over 1. I've tried the whole numbers first. That's not to say fractions can't work. But I'm going to try positive 2 over 1. Let's see if that works. So first of all, I'm going to write 10, the third power, and negative 17, negative 7, and 2. Again, all the powers are there, 3, 2, 1, and then the constant. And I'm going to try writing a 2 out in front out here. Let's see what it gives me. If I drop down my 10, I multiply, just 20, and then I add. That's 3. That gives me positive 6. And then I'm going to add, I'm going to get negative 1. 2 times negative 1 is negative 2, and yay, it worked. So that tells me x equals 2 is a solution. And when you guys do your homework and things, make sure you write x equals 2 somewhere. Okay, I can see it here, but write it somewhere so I know where my solutions are. I can tell where your solutions are, your answers are. Okay, and now to find the other ones, again, this is a third power, so we should have a total of 3. I take this stuff right here and I change it back to a polynomial. It's 10x squared. Remember, if this was a third power, this is always one less. 10x squared and then plus 3x minus 1. And then we're going to try and factor that. Okay? Screw this up here a smidge. Okay? If I look at my factors of 10, I have 1 and 10 or 5 and 2. And the factors back here are only 1 and 1. Well, if I did a 5x and a 2x, and I plugged 1 and 1 in there, I think I can get it if I did positive 5 and negative 2. 5x minus 2x gives me the 3x that I need in the middle. Okay? So I got it to factor. And again, if I want to find the zeros, if I want to find the actual solutions, I could set each of these things individually equal to 0. I could say 5x minus 1 equals 0 and 2x plus 1 equals 0, and then solve it. Or hopefully, by now we've done enough of this factoring, you guys know the little shortcut. It's the opposite of the last number, 1 over 5. This would be negative 1 over 2. And there are my other 2 solutions. So we got a grand total of 3. Okay? And again, if I go back up to the top, as 1/5 and negative 1/2, one of the possibilities. Okay? Here's 1/5, 1 over 5. Okay? And there's 1/2, the negative 1/2. So it is one of the possible solutions. Okay? By the way, we could have tried negative 1/2 out here. Okay, can you do the synthetic division stuff or substitution stuff with fractions? You sure can. It would end up giving you a 0. Same thing if you did 1/5 out here. It would end up giving you a 0. So, but again, to keep it simple, I try to start with the whole numbers. The whole numbers, yeah. Okay? All right, so that's kind of the gist of it here today. Okay? But it's kind of a pain when you get a whole bunch of possible solutions. How do you know which one to start with? Okay, get this guess and test method. Now granted, I got lucky. I got it on the first try in this one. And on the problem before this, I got it on the second try. But sometimes I've been here, we didn't get it till the third try, the fourth try, the fifth try. And, that's kind of a pain. Okay? Well, that's what I said here. Just randomly guessing and testing to see which one gives you a 0 can be very time consuming. Okay? So one thing that we can do that can ease the pain a little bit is that we can use our calculator to help us find one of the zeros as a starting point. Okay? So I'll show you how this works here. Here's a little example right down here. Okay? And what we want to do is I want to do the same exact thing, but rather than listing out all the possible solutions, okay, all the P's and Q's and then guessing and testing it, okay, I'm going to kind of first set it up here. Okay, I have a 4, 3, 2, negative 1, and negative 1. Okay, what I'm going to do is I'm going to use my calculator to help me determine what number should go out front there. Okay, and the way it says here, we're going to do this by graphing the function and looking for any zeros on the calculator. So here we go. Let's try this. I'm going to go to y equals, okay, and I think I have this on here, 4x cubed plus 4x squared minus x minus 1. So take a second here, get your calculator, okay, type that equation in, and then graph it. Oops, and I'm going to press zoom, and I'm going to hit number 6. Remember, zoom 6 resets your calculator to the normal 10 by 10 window, and it's going to look something like that. Okay, it's a little bit hard to tell, okay, but it looks like it has 1, it goes up and over, down, and it looks like it has 3 solutions. And going back to this here for a second, I see x to the third power. It has a degree of 3, so it should have 3 solutions. Okay, well, I got to find them. You know, it's kind of hard to tell there, isn't it? What I'm going to do is I'm going to use the zoom button on my calculator. So right up here at the top is the zoom, right in the middle. Okay, and I'm going to zoom in. I'm going to go down to number 2 and press enter. And if you can, my little cursor starts out there at the origin. Okay, I'm going to move it, well, right over to that area, and I'm going to press enter again. And what it does is it zoomed in on that area. And now we can clearly see that it has 3 solutions, 1, 2, and 3. Okay, and I need to find one. It's a little bit hard to tell here, but this is 1, this is 2, this is -1, this is -2. So it looks like one of the zeros is that x equals -1. Okay? Now, again, remember a 0 is an x-intercept, and it has 3 of them. Okay, it looks like one of them is at -1. And we have to be sure. Okay? A couple ways to make sure is I can go second trace, and I can do my 0 thing. Okay, and I'm going to erase this here so I can see better. But I'm looking for this one. I'm going to go, the left bound is going to be down below it, down here. Press enter. The right bound, I'm going to go up above it, press enter, and then yes, I'm going to get close. And look at that, it does tell me that -1, 0 is a solution. Okay. And again, we're going to use our calculator to help us find 1. Okay. And another really easy place to tell, an even faster way maybe, is if you go to your table. If I go second graph and go to my table, and look what happens when x is -1. When x is -1, did it give me a 0? Yes. Okay, so that's another way you can kind of quickly tell. But if you notice, there aren't any other ones there, are there? And again, the way that our calculator is set up is it's only going to give us the zeros when it's a whole number, or a nice number, in an integer, let's put it that way. Okay? But at any rate, yeah, that just means these other ones over here, these other ones are fractions. But we got one of them. Okay, and that's the number that I'm going to use to start out front here. So there's -1. Okay? And according to this, if it is a solution, it should give me a 0. So let's try it. So I'm going to drop down my 4. -4, 0 when I add them. 0, -1, +1, add them, and I get 0. Okay? There we got it. Okay, so I know that x equals -1 is one of my solutions. And the rest of it's the same here. Okay, if I translate this back into a polynomial, I get 4x squared plus 0x, I don't need that there, -1 equals 0. Okay, now bad news. The ones we've done so far, this has been factorable. Actually, it still is factorable. Okay? Okay, did I do that right? I think I did that right, yeah. Okay? So now what? Okay, well, I can set these equal to 0. Okay, so I could add 1, 4x squared equals 1, divide by 4, so x squared equals 1/4, and then to get rid of the square, I square root both sides. Okay, and x would equal plus or minus. Remember when we square root a fraction, we square the numerator and denominator, and I get plus or minus 1/2. Okay? And if you look closely here, again, this was the number 1, this was 2, this was -1, -2. Right here, this is -1/2, and that's +1/2. Okay? Which does fit the bill. Okay? And I did get 3 answers. 1, 2, 3. Okay? But the whole gist of this is then we're going to use our calculator to help us find the first one. Okay? But that's how we're going to do it today. We're not going to have to do the guess and test method. We're going to use the calculator and synthetic division here. Okay? All right, here's another one. Let's try this. Same thing. Okay, and before I go to my calculator, I'm going to kind of just do the setup here. 1, 2, 4, and 8. And again, all the exponents are accounted for. And I'm going to use my calculator to help me find one number that goes out there. Okay? Let's try this one. So I'm going to go to y equals, clear out my old one. Let's take a second and type this in. X raised to the third plus 2x squared plus 4x plus 8. And I'm going to graph it. Oops. I'm going to go back and I'm going to hit zoom number 6. Can I get that picture? Now that's kind of a weird looking picture. Okay. According to my fundamental theorem here, I have an x to the third, so I should get 3 solutions. I should get 3 x-intercepts. Right now, this is only looking like 1, isn't it? Okay, so what does that mean? Well, the calculator is only going to tell you the real solutions. Okay, so if there's got to be a total of 3, and it's only showing 1 real solution, my guess is there's 2 other solutions, but they're imaginary solutions. Okay, and looking at my graph there, if I was to make a guess, to me that looks like it's -2. Now I'm going to do this kind of the fast way here. I'm going to go second trace to my table, and if I go to -2, and if I look right there, lo and behold, it does give me 0. Okay, but I need to prove it. Okay, so if I did -2 right here, okay, let's work it out and see if it equals 0. Let's drop down my 1. Multiply is -2, and I add, I get 0, 0, 4, -8, and 0. It works. So that tells me x equals -2 is one of my solutions. Okay? And this is very similar to the last one. Okay, if I change this back to a polynomial, I get x squared plus 0x plus 4. And I want to find the solutions to that. Well, that's not factorable. It's not x plus 2 and x minus 2. Because that would work if that was subtraction. Okay, but it doesn't work if it's addition. So what do? Well, I can just solve it. Let's use algebra. Okay, what if I move the 4 to the other side? And then to get rid of the square, if I square root both sides. They cancel out. And remember, before I do anything, I always get a plus or a minus when I do that square root. And the square root of 4 is 2. But because it's a -4, it's also going to have an I on it. Okay? So it has 1 real solution, and then has 2 imaginary solutions. Okay? And there they are. Okay? All right. Okay, I think I have 4 total, or a couple more here. Okay, and each one of these is a tiny bit different, so it's important to do all of these. Okay? Here's another one. Now this one's kind of a special one. If I do my setup, I have 1x to the 4th, -3x cubed, 1x squared, minus 3x, but it's missing something. What? Well, wait a minute. It has the 4th power, the 3rd power, the 2nd power, the 1st power. It's missing the constant at the very end. So I need to add a 0 at the very end. Okay, but all the terms have to be accounted for. Okay, then I'm going to type this in my calculator. Okay, I'm going to go to y equals, and I'm going to type x raised to the 4th minus 3x to the 3rd minus x squared minus 3x, and I guess I can put the 0 in there. I don't necessarily need it on my calculator. But if I press graph, okay, and again, when I'm looking at that, I'm looking at this. The 4th power tells me I should get 4 answers. Well, my calculator there, it looks like it's showing me 2. It looks like it's showing me one of them right here at 0, and another one out there about 3.5, between 3 and 4. So again, this is showing me the 2 real solutions, and if I need 4, my guess is I'm going to get 2 imaginary ones. And just to double check here, I'm going to go with this one. That looks like it's at 0. If I go to my calculator, my table, and when x is 0, lo and behold, yep, 0 is a solution. Okay? Okay, so I'm going to try this once. I'm going to plug in a 0. I'm going to drop down my 1. I get 0, -3, 0, 1, 0, -3, 0, and it works. Okay, so I did get a remainder of 0. Okay, so I know it seems kind of weird, but x equals 0 is one of my solutions. Okay? Well, let's take this leftover stuff here, and I change it back to a polynomial. That's going to give me 1x to the third minus 3x squared plus 1x minus 3. And I want to solve that. Okay, and like I said here, mainly the way that we solve this leftover piece here is we do factoring. Okay, well, a while back here we learned how to factor something, and factor one of these, and what's kind of weird about this one or different is that it has 4 terms. Do you remember the name of the process that we use when we solve something that has 4 terms in it? It starts with G. Yeah, it's called grouping. Okay, and the way that grouping works is I group the first 2 terms together and the last 2 terms together. And then I look to factor out a greatest common factor out of each term. And if I look closely at this one, I think I can take an x squared out of both of those. And I would get an x minus 3 left over. Okay? When I look at the second group, nothing can be taken out of that. Okay, so it's just going to stay x minus 3. Okay, and then once more with grouping, in the second round of it, we factor out the little expression that they have in common. Okay, so this looks like x minus 3 can be taken away from both of them. Okay, and what's left over is I get x squared plus 1. Okay. Okay, and if I keep on solving here, so I missed this before. Right here, I'm going to get x equals 3 as a solution. Okay, so there's a second solution. And then, how do I solve that one? Well, let's set it equal to 0. It's not factorable. If I move 1 over, and then I square root, oops. The square root of negative 1 is I. Plus and minus I. Okay, so I have 1, 2. X equals 3 is a third solution, and then my original one, x equals 0, is another solution. And it's going to be helpful for me if we could bring that one down and just kind of write them all together. Okay, and I think when I did this a minute ago, how come that 3 is not graphed? Oh, because my window's messed up, you know. Yeah, I don't know why that's, Did I type something in wrong on my calculator? Let me go back a second. X to the 4th minus 3x squared. Oh, shoot. Right here is supposed to be a plus x squared. That's still okay. Yep. Okay, I had the wrong equation in there. All it did is it changed this right here. So it actually did have 2 nice numbers to begin with, 0 and 3. We went with the 0. That's okay. Okay, and it yielded us, or in the end here, it gave us our solution of 3. Okay, I could have started out there with 3 at the very beginning also. Again, I had the wrong equation, but no harm, no foul, all is good. We went with the 0, everything else worked out. Okay, but it does have 2 real solutions, the 0 and the 3, and then it has 2 imaginary solutions with the plus and the minus I. Okay, but I think you're getting the gist of it. The whole idea here is to use our calculator, and you can pick one of the 2. You can't pick both of them, but you can pick one of them. Okay, and then you have to do the synthetic division and prove it, and then use factoring to do the other ones. What I sometimes get is people see 2 nice solutions, and then they just do the synthetic division thing and show me how 0 gave me a 0 and how 3 gave me 0. No, you're only allowed to use the calculator for one of them. Okay, so you're only going to do the synthetic division thing one time, and your other one's going to come from your factoring. Okay? All right, I think I have one last one here. Yes, actually I got 2 left. Okay, and again, this is a little bit different than the last one. I'm trying to cover all the different types of problems you're going to see here. Okay, I'm going to go back and type this one in. 4x raised to the 4th, and hopefully I copy it right this time. X to the 3rd minus 8x squared plus 13x minus 12. 4x to the fourth plus 13x squared minus 8x squared plus 13x minus 12. Okay, I'm going to graph it. Okay, and according to this, again, I should get 4 solutions. Okay, when I look at my calculator over there, it looks like it's showing me 2 real solutions again. It looks like one of them is going to be -4, and the other one is a little bit before 1. It's going to be a fraction. If I go to my table here, just to double check again, okay, and look right there at the top, -4 is the solution. Okay, so again, I'm going to do this business. I get 4, 13, -8, 13, -12. Those are all my coefficients. All the powers are there, the constant is there, all is good. And I'm going to try -4. And according to this, -4 should give me a 0. I'm going to try it here. When I multiply -16, I add, I get -3, positive 12, I'm doing this kind of fast. -16, -3, positive 12, and 0. Okay, so right there, I know that x equals -4 is a solution. Yep. Okay, so there's one of my zeros. Okay, we then take this polynomial part right here and change it back into 4x cubed minus 3x squared plus 4x minus 3. And once again, just like the last one, this one has 4 terms in it. Excuse me. So we're going to do grouping. Oops, and this is all equal to 0, by the way. Oops. Okay, so let's do grouping. I'm going to group the first 2, and I'm going to group the last 2. This is very similar to the last problem. Okay, I'm going to take out x squared. I think they both have an x squared in common. And I get 4x minus 3 left over. This one doesn't have anything in common. I get 4x minus 3. I just bring it down. And then with grouping, if you remember, we take out the common expression, 4x minus 3, and I end up with x squared plus 1 left over. X squared, remember, when this all goes away, it turns into a 1. Okay? Oops. Okay, so if I keep on solving here, if I do my little shortcut down here at the bottom, that's going to be positive 3/4. And this one right here, it's not factorable, but if I set it equal to 0, if I subtract 1 and then square root, remember the square root cancels out the square, I'm going to get plus or minus I again. Okay, so I get 1, 2, 3, and then my original one, which was -4, I'm going to write that down here with the others so I can find them. There's 1, 2, 3, 4 solutions. Hey, you're going to encounter this a little bit, this grouping stuff again. Okay, but notice we're getting a couple I's. Okay, yeah. Okay, I know I'm going kind of fast here. Feel free to rewind, push pause, go back and revisit it if I lost you. Okay, and here's the very last one for the day. Okay, and this one says it's kind of a special one. Okay, well, let's see what's special about this one. Okay, I'm going to kind of do the setup first. Okay, and I think, I see one thing that's kind of special right away. I see a 1x to the fourth, a 1x cubed, and if you look carefully, it's missing the x squared term. So I have to put in a 0, and then -8, and -8. Okay, so there's one, and you're going to see 1 or 2 of these today, that it's missing a term. Okay, so there it is. Okay, let's graph this, and let's see if we can use the graph to get us one of the numbers to start with out here. Okay, so I'm going to go x to the fourth plus x to the third minus 8x minus 8, and I'm going to graph it. Okay. Okay, so this one looks like it has, well, we need 4. I see a 4th power, so we're going to get 4 eventually. Right there, it's showing me 2 real solutions. And it kind of looks like they're 2 nice ones. Looks like one of them could be -1, and positive 2. Let's pick one. I'm going to go to my table just to make sure. If I go second graph to my table, there's one. Negative 1 gives me a solution, and so does 2. So let's just pick one of them. I'm going to pick the 2. And when I do it, it should give me a 0 out here. So I'm going to go down to 1, 2 add, I get 3, 6, 6, 12, 4, 8, 0. Yes. So x equals 2 is definitely a solution. Okay. So now what? Okay. So I'm going to take this leftover stuff here. Okay, and I'm going to change this into x cubed plus 3x squared plus 6x plus 4. Okay. Now what? Okay, there's 4 terms, and normally we try to do the grouping thing. Okay, and if I group these, I can take an x squared out again, and I get x plus 3. This one I can take a 2 out, and I get 3x plus 2, and now I run into a problem. I run into a problem because those two expressions are not the same, and when we do grouping, they usually have to be the same. So now what? Okay. Well, now what we do, okay, is we have to go back, okay, and then we have to use. What we have to do is we have to graph this one, okay, and do the synthetic thing again twice, a second time, I should say. Okay. So I'm going to do synthetic division with this. It's going to be 1, 3, 6, and 4. And I'm going to graph this equation to see if it gives me a 0. Okay, kind of a weird thing here. Okay, but now I'm going to graph x to the third plus 3x squared plus 6x plus 4. And I'm going to graph that. And again, that looks like it's just one solution. Looks like it's right there at -1. And if you're watching here, if I go to my table, -1 does work. Okay, so I'm going to put a -1 out here. And I'm going to do it again. I'm going to get -1, 2, -2. Uh-oh. -1 does, yeah. What did I do here? Add it to -2. Oh, yeah. 4, -4, and 0. Okay, so there's another one. X equals -1. There's a second solution. Okay. Okay, and I'm going to keep on going here. Let's see what I have left here. This is x squared plus 2x plus 4 equals 0. Okay, and I'm going to try to work with that. Now, most of the time, again, we factor it. Well, if I tried factoring this, my only choices are x and x, 1 and 4, and 2 and 2. And the bad news is I don't think any of those can give me a 2. Okay, so now what do we do? Okay, it's not factorable. So now what? Okay, doesn't have any solutions? Oh, it has solutions. They're just not very nice ones. Okay, and notice this down here to the second power, a square, and a second power is called a quadratic. So you guessed it. Okay, the last thing we're going to do with this thing is we have to use the quadratic formula. Okay, and one that is not factorable. Okay, so let's use our quadratic formula. A is 1, B is 2, and C is 4. Okay, so we're going to do x equals, remember the quadratic formula is the opposite of b, plus or minus the square root of b squared. 2 squared is 4, minus 4 times 1 times 4, all over 2a, which is 2. And again, I'm doing this really fast here. Okay, if you were to use your calculator, or maybe in your head, this is 4 minus 16 turns into -12. Okay? Now negative 12 is not a perfect square. Okay? But it can be simplified. We can break it apart. And if you look at your factor sheet, 4 and 3 are the two factors we're going to use, and that turns into a 2. So negative 2 plus or minus 2, and because it's negative 12, we're going to have an I in there. With the square root of 3 all over 2. And you might be thinking, are we finally done with this problem? We're really close. Okay? If I look closely, all 3 of these guys can be divided by 2. They turn into 1s. So my grand finale answer is negative 1 plus or minus I with the square root of 3 all over 1. I'm just going to leave it like that. Okay? So this has 2 imaginary solutions. And then way back at the beginning, we found 2 real solutions. Okay? So long story short, when you graph these things, okay, we use the graph to give us one of the zeros. We saw a couple problems where it had 4 terms left over and grouping did work. If grouping did not work, okay, graph this equation. Okay, which was this guy over here, to find another solution and show that it equals 0. Okay, and then the leftover stuff, once you get it down to a squared term, a quadratic, okay, most of the time it's going to be factorable. But if it's not factorable, you're going to have to use the quadratic formula. And you're probably going to see that a couple times today as well. Okay? All right, so today your assignment's a worksheet. Okay? Make sure you check your answers. Okay, this last chapter you guys did a much better job of that. This is the last assignment of new material for the second half of chapter 5. But check your answers. And if you don't get it, let me know. Email me. Okay, join our Google Meet sessions. Okay, I've only had about 2 people at a time join those. That's a great time to ask for help and ask questions. It's a perfect time. And we'll be having, stay tuned to the stream. I'll post on the stream when the next Google Meet session is. All right, thanks for tuning in.